Synthetic division is a lot like long division. I'm assuming you watched the long division video first before we started doing this. It's a lot like long division, but it's a lot simpler as long as you remember what's going on. So in synthetic division, we're basically going to write the coefficients of these terms. So 6, negative 19, 16, and negative 4. And then what we're going to do is we're going to take the root and put it in this spot. So for example, if x minus 1 is a factor, then x equals 1 would be the root. And so what I'm basically going to do is I'm going to take whatever the roots are and I'm going to substitute them in. Now I know from the other side of this worksheet that x equals 2 is a root that works, but I'm going to try one that doesn't work first just to make sure that we know what it looks like when it doesn't work. So if I sub in 1, how I'm going to do synthetic division is I'm going to take the 6, move it down, multiply 1 by 6, and then add. So I get negative 13. Multiply 1 by negative 13 and put that here. Then add. Multiply 1 by 3 and then add. So I end up with this 6, negative 13, 3, and negative 1. I'll explain what everything looks like. If I factored this, if I wrote this as a long division problem, 6x squared minus 13x plus 3 would be up here, and then I'd have all this stuff, and then the last number would be negative 1. This number is my remainder, just as it was in the long division video. 6x squared minus 13x plus 3. So essentially what happens is this was an x cubed, this was an x squared, this was an x, and this was a constant. Everything loses a power. So this essentially becomes x squared, this becomes x, this becomes the constant, and then this becomes the remainder. So that's kind of what it looks like in synthetic division. Now I'm going to show you what happens when it works. So I know that 2 is a root that works. 6, negative 19, I don't need the plus sign. 16 and negative 4. So I'm going to put the 6 down here. 6 times 2 is 12. Then I add negative 7. Negative 7 times 2 is 14. I'm sorry, negative 14. Then I add 16 plus negative 14 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. Anytime I have a remainder 0, that's good. That means that it is a factor. This is an x-intercept. So 2 is an x-intercept. So I can factor this into x minus 2. And then remember that all of these lost a degree. So it went from x cubed to now I have 6x squared. This negative 7 is going to be a minus 7x. And then I have plus 2. And then likewise, I can factor this the way that I did before on the other side of the page. So x minus 2, and then I have 3x plus 2, 2x plus 1. Since I'm finding x-intercepts, this equals 0. I have 2, 0, negative 2/3. Oh, shoot. I did the same thing on the other side of the page. So these should be minus signs. So I have 2/3, 0, and 1/2, 0. Sorry about that. Okay, now here is where synthetic division gets a little bit complicated. So negative 3/2 is the root. So if I put 2, 7, negative 4, negative 27, negative 18, this should work out really well because I know it works. So I can carry down the 2. 2 times negative 3/2 is negative 3. That becomes 4. Negative 3/2 times 4 is negative 6. So that becomes negative 10. Negative 10 times negative 3/2 becomes 15. That's negative 12 when I add. Negative 12 times negative 3 halves is 18, and I get a remainder of 0. So that's good. The remainder of 0 means that I have a winner. So then this is wrong. I'm warning you right now, this is wrong. The temptation is to write 2x plus 3 times 2x to the third plus 4x squared minus 10x minus 12. It's a temptation because I know that if negative 3 halves is a root, that means that I typically write this as 2x plus 3 as my factor. It is wrong because if I distributed this out, and I'm not going to distribute it all out right now, but if I distributed this all out, I would get 4x to the fourth. Notice that I had 2x to the fourth. I can't get 4x to the fourth. So what's important to know about synthetic division is if you're doing synthetic division, if you take negative 3 halves, you're not using 2x minus 3 as your factor. You're using x plus 3 halves as your factor. So whatever you put in this little mini box, that's what you're using as your quote unquote factor. So it's x plus 3 halves. And that gets a little bit messy to see. So I have 2x to the third plus 4x squared minus 10x minus 12. Now it's not too bad because notice that all of these have a GCF of 2. So if I pulled out the GCF of 2 and multiplied it into here, into this green one, so I take it out of the black one and put it into the green one, then it ends up not being so bad after all. And then I can just continue to factor things the way that I did on the last page. So if I remember correctly, x plus 1 was a factor. So that means that negative 1 should work. And then I can continue to do this with these coefficients. So 1, 2, negative 5, negative 6. And that works out. So I end up doing the exact same thing I did on the other side. I have 2x plus 3, x plus 1, and then I have x squared plus x minus 6 from this, which then can factor into x plus 3, x minus 2. And I can figure out that my x-intercepts are at negative 3 halves 0, negative 1 0, negative 3 0, and 2 0, which should be the same as the other side. It was way down there, but those are the same x-intercepts. It should be because it's the same problem. Okay, number 3. I'm going to do the rational root theorem. So plus or minus 1, 2, 3, and 6 over 1 and 2. I'm going to try nice numbers as much as I possibly can. So I'm going to try 1, 2, negative 3, negative 11, 6. I'll pull down the 2. So 2 times 1 is 2. Add 1 times negative 1 is negative 1. Add. This is not going to work. I have a remainder. So the remainder means it doesn't work. One thing that's really nice about synthetic division is if you're good at multiplying and adding, you can do this pretty quickly. So now I'm going to try negative 1. So pull down the 2. 2 times negative 1 is negative 2. Add, and I get negative 5. And this looked like it was going to work, but it ended up not working. So I guess that was another fail. So let's try 2. Pull down the 2. 2 times 2 is 4. Add that and I get 1. 2 times 1 is 2. Add that and I get negative 9. Negative 8. No, that's not going to work either. So sometimes this takes a little while, but I'm just going to go from easiest to hardest. It's easiest to multiply by 1 and 2. So that's what I'm going to try. 2 times negative 2 is negative 4. Negative 7 times negative 2 is 14. 3 times -2 is -6. And I finally have a winner where my remainder is 0. So I can write this as x plus 2 times 2x squared minus 7x plus 3. Once again, remember that all of these powers end up being reduced by 1 in the algorithm, and then this is the remainder. So now that I have that, I can finish factoring this. So f of x equals x plus 2 times 2x minus 1 times x minus 3. So my roots, my x-intercepts are at -2, 0, 1/2, 0, and 3, 0. The last thing that we need to show you in synthetic division is that if I have x cubed minus x minus 6, well, I can do the rational root theorem. Plus or minus 1, 2, 3, and 6 are my choices, since the leading coefficient is 1. I'll try 1. It may or may not work. But one thing that's important to note is that I have to put a placeholder spot for x squared. So f of x is really x cubed plus 0x squared minus x minus 6. I need that placeholder spot or this doesn't work. So that is very important. Place holders where coefficient is 0. That is huge. You must have a placeholder where the coefficient is 0. So let's try 1. That would mean that x minus 1 is a root. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -1 plus 1 is 0. This is not going to work. So I will try, I will try -1, which means that x plus 1 would be a root. So I'll pull down the 1. 1 times -1 is -1. 0 minus 1 is -1. Add 1, I get 0. This, once again, is not going to work. So I will try 2. Pull down the 1. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. And this one works really well. So x minus 2 is a root. And then I have x squared plus 2x plus 3. And if I look at x squared plus 2x plus 3, that does not appear to be factorable. So it looks like I have a root at x equals 2, and then I would have to do the quadratic formula on this one. So x equals -2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And just based on looking at this, it appears to be imaginary roots. So my only real x-intercept is at 2, 0. And if I wanted the complex solutions, I would say -2 plus or minus, it looks like the square root of 8, so it's 2 root 2i, and I could simplify that to -1 plus or minus root 2i if I wanted to. So this is my only real root, and then I would have 2 complex solutions as well.